2. Go.
Okay, Assalamualaikum warahmatullahi wabarakatuh. Today, my group will present about water turbine hydroelectric project. We from group 3. My name is Izul Aiman bin Izzuddin Effendi and my matrix number is 200625. Assalamualaikum and I hope Dr. Adi in a ping of help. Okay. First, we go to the introduction. When we talk about water turbine, it's related to hydropower. So, what is hydropower? Hydropower is a type of energy that cycles the intensity of water moving. For example, water streaming over a cascade to produce power. When we talk about turbine, it should consist of water. So, water is the basic thing to turn the turbine. To do this, water is bridled to gathering in it hydroelectric dam. So we come up with 4 objectives, which is to develop the understanding of the theory behind the conceptual of water turbine in hydroelectric system, to apply fluid mechanics knowledge in real life situation, 3, to apply the concept of fluid mechanics that have been learned into daily life and surrounding, and last one is to understand the main problem about the usage of water turbine in hydroelectric section.
Hello, for the next present is So for the literature review, my name is Nurata Shafitri Binti Salamat and my matrix number is 203718. Okay, for the first innovation, it's during the Han Dynasty period between 202 BC until 980. It is to pound and hull grain, break ore, and in early paper making. Next. Okay, next for the Francis turbine. In 1827, a French engineer called Benoit Furneron developed a turbine capable that produced around 6 horsepower. In 1829, a British-American engineer named James Francis developed the modern water turbine that can be seen in the world today. Next. Okay, for the Pelton wheel, in the 1870s, an American inventor named Lester Allen Pelton developed the Pelton wheel and impulse water turbine, which he patented in 1880. For the advantages of water turbine, it is mostly used by water, so it's a clean source. Next, it relies on water cycle, which is driven by the sun, making it renewable power source. However, there are some disadvantages for water turbine. First, the cost is expensive. The electricity prices increases as how much water is used. Next, it can impact quality and flow. There are 2 types of water turbine, which are reaction turbine and impulse turbine. Reaction turbine develops torque by reacting to the pressure or weight of a fluid, while impulse turbine is driven by a high-velocity jets of water or steam from a nozzle directed to vents or buckets that attach to the wheels. Next. For the efficiency, it can be as high as 95% for large installation. So for smaller plants with less output power less than 5 megawatts, it may have efficiencies between 80 to 85%. So that's all from literature review.
Assalamualaikum. My name is Muhammad Adal Umar Bisni. My matrix number is 200596. So I will explain about concept of the system. So the system is about the conservation of energy using water turbine. Basically, water turbine is used as alternative ways to change the kinetic energy to mechanical energy. And after that, the metal shaft in generator convert energy from the turbine to the electrical energy, and then it will supply by the transformers to the nearest home. So how this kinetic energy come from? So it's come from the water that's moving from the dam, which is from the high place, and then fall in vertical position to the water turbine. So that will give the water in the high velocity and rotate the turbine. So the water flow to the turbine at constant velocity and undergoes the conservation of energy. For our project, we will use the Bernoulli equation to calculate the conservation of energy and efficiency. So this is the formula that we use, and basically I have mentioned it in our reports. So that's all for my part.
Okay, we continue with the technical drawing. So before I start, let me introduce myself. Hello, doctor. My name is Muhammad Fazilio bin Abakar, and my matrix number is 203715. So for the technical drawing, I will be explaining what the part and how the mechanism works. So basically, how these things works is when you pour water into the tub, so the water will flow from the power water pump and go to the straight to the upside of the tub. So basically, when we supply power to the water pump about 5 watt power, so it will push the water up to top and it will flow from the water slider and going into the motor and it will turn the turbine. So once the turbine get higher velocity, so it will can reach to power, it will generate power up to 20 watt. That is how it works. So next, this is for the technical drawing. So here we got top view, front view, right side view, and isometric view. All right, next. So this is basically how each of the part. So this is the turbine, the motor, the water pump, the water tub, the connector, and the last one is the water slider. That's all from me. Thank you.
Hi, my name is Nur Izzati Berry Binti Rashid and my matrix number is 202790. I am going to present the result and calculation and discussion as well. So as you can see in the slide, that we use the Bernoulli equation that have mentioned from earlier by my teammates, that we are using it to calculate the power, and from the power we can calculate the efficiency of our design. We use the measurement using by our design that have been done and explained by our team member Fazil. So from this calculation, we only get 16.3% of efficiency. I will explain why we get only 16.3% in our discussion. Next. Okay, so based on our result that was recorded, our hypothesis is correct, which is the renewable energy can be created when a moving water supply applied to a turbine. However, there's a few factors that contribute to the efficiency of the hydropower turbine. So the most important factors is the height of the tank and the velocity of the water. We get only 60.3% of our efficiency because we, based on our model that we have done, is only have height of 40 meters, which is quite low for a turbine. And the water supply that we use on the normal water, so the velocity of the water is only 5 meters per second. So to increase the efficiency, you can increase the velocity of the water and increase the height of the water tank. So that's all from me.
Assalamualaikum. My name is Muhammad Afiq Azizi bin Ajman and my metric number is 200802. So there are 4 recommendations that our team would like to suggest for the water turbine. First of all, project designers should apply environmental and social criteria to various project alternatives early in the planning process. This is to ensure the selection of the most appropriate alternative for the development. Second, the selection of projects and project management should be made on the best practice consideration, which include the following issues such as the social impact, energy production, and develop river basins. Then the third one, we also recommend that project designers should clearly identify any specific environmental and social criteria that apply to hydro project of different sizes and types, and also to clarify the negative and positive impacts in every action that will be taken. And the last one, we also recommend the renewal and upgrading of existing power plants by adding hydropower facility to existing them should be promoted. This is because we can see that the potential to provide more power or system flexibility in economic manner is still there in the old existing power plant. That's all from me. Thank you.
Okay. In
Thank
conclusion,
you.
we're referring to our activities project. First, the group managed to develop the understanding of the theory behind the conceptual of water turbine works in order to produce hydroelectric system that be presented by puzzle. And the group also be able to apply the fluid mechanics knowledge in real life because the project was meant to relate about the environmental issues. And the last one is the group managed to understand the main problem of this project, such as efficiency of the hydro turbine, which we have to increase the efficiency in order to deliver less energy to provide the huge level of the energy. That's all from us. Thank you.